Guys, this is the video for 1.2, combining like terms and equivalent expressions. This is the second lesson in our Unit 1 Algebra Foundations lesson or unit. So the first thing we want to talk about is we're going to concentrate on combining like terms first, then we'll talk about equivalent expressions. So the first thing we need to know is, what is a term? So a term is let's see, it's any number, variable, or combination of a number and variable. Of a number and variable in an equation or expression. Okay, so that's what a term is. It's just a number or a variable or a combination of a number and a variable inside of an equation or an expression. So we're going to take a look at a couple different types of terms. So sometimes we'll have expressions that have just one term. So these ones all across the top right here are one-term expressions. Even this last one right here and this one right here. These are only one-term expressions. These ones down here in the next row, these first three, oops, I didn't mean to turn that, sorry. I was trying to turn it so I could write a bracket and oh my goodness, I can't do it upside down. Sorry. Okay, so these first three, this one, and this one, these are two-term expressions, and this last one is a three-term expression. And they could be even higher than that. They could be, you could have ones with as much as, 10, 12 different terms, really. I mean, it's pretty much infinite. So what we want to know, though, is how do we determine if it's a three-term one, like this one here, or if it's a one-term one like this? Because to me, this one up here looks like it could be a two-term just as much as this one's a three-term. So let's talk about how we know. So if you look at these two, and these are on your paper, this one right here, this is a three-term, and this one is just one term. And hopefully what you can see, or what, after looking at it, maybe what you'll be able to determine is that what we get is if there is a subtraction or an addition sign in there, that's what separates the terms. Multiplication and division don't separate terms. Addition and subtraction are what separates terms. So this is one term here, this is the second, and this is the third. If you're looking at this one-term one over here, you can see there's no addition or subtraction. I mean, there's a negative in front of the two, and if we were to put something right here, then it would separate it, but there's nothing there. So this one is considered one term, even though it could look almost like it was three terms if we wanted. So what separates terms? So addition or subtraction. So, oops, I forgot a T in there, sorry. Subtraction symbols separate terms. Okay, only addition or subtraction, not multiplication or division. So that will kind of help us to determine which terms are separated and how we can start to combine them together. So let's scroll up a little, back up here. So let's talk about how we combine like terms, or how do we know which terms can be combined together. So if you look, this one has just an X, and this one has just an X. And there's some other ones. Here's one that's just an X. This one is just an X here. These ones can, over here too. All of these would be able to, if we were putting these all together, we could combine all of these terms together because they all have that same variable combination, just an X. Okay, so all of those can be combined together. But what we can't combine is this one here and this one here. We can't combine those with those same ones we were just looking at because they have the exponent on them that makes them different. Okay, x is not the same as x squared, and x squared is not the same as x third. So if we had to combine all of these terms together on our whole screen right here, x to the third power, or 8 times x to the third power, could be combined with this one right here, but that's the only one it can combine with. And this one right here with the x squared, there's not another x squared on this page, and so there would be nothing for it to combine with. It would just be all by itself. Okay, if we wanted to combine something with this one right here, the 3y squared times z, it would have to have that same variable combination. So it would have to have a y squared z in order to combine with this term here. They have to have that same term combination or variable combination and exponent combination in order to be combined together. Okay. All right. So now that we know that, let's practice combining like terms. So here's a definition of like terms for you. Like terms have the same exact variable combination so that they represent the same thing. So let's pretend like we have 2 grocery bags, and in our first grocery bag, we have 5 apples and we have 6 pears. And in our second grocery bag, let's say we have 7 pears and 9 apples. First of all, let's represent each separate grocery bag as an expression using some variable to represent apples and a variable to represent pears. Now, normally most of us would probably say, okay, let's use A for apples and P for pears because it just makes sense. But you don't have to use A and P. You could use any variable you really wanted, just as long as you stay constant. So I'm going to use the A for apples and the P for pears. So if I was going to write an expression to represent this first grocery bag, I'm going to write, I have 5 apples, plus in the bag, I have 6 pears. Now notice how I didn't put 11. I do have 11 objects in that bag, but I'm separating because technically I can't combine apples and pears together. I have to count them separately, away from each other. So for this second bag over here, I would do 7 pears plus 9 apples. Now, if I wanted to combine these 2 bags together, say I get home and I want to put them in my fruit basket and put them all in one fruit basket, I can combine my apples with these apples, and I can combine these pears with these pears, but I can't combine them all together. So I would end up with 14 apples and 13 pears, because all we did was add those coefficients together. Okay, so that's combining like terms. So now let's talk about equivalent expressions. Oh boy. Okay, you guys have some expressions on your... Oh, I need to pull that up. Hold on one second. Okay, you guys have on your paper a list of 9 different... Okay, I pulled up the wrong set of notes. You guys have a list of 9 different expressions. What you need to do is go through those expressions and simplify them. Some of them need to be simplified, some of them don't. And then we need to find the ones that match. So I'm trying to pull them up here myself, and I'm just not doing a great job of it. Okay, here we go. So you can see the first one. It's thinking. Okay, you can see the first one is 4x minus 3, and I'm just going to kind of write these around so that I have them on my screen. So oops, what is going on? No, stop it. Okay, so we have 4x minus 3 is one of them, and that one doesn't have to be simplified. Then we have 4 times x minus 3. That one needs to be simplified. You need to distribute the 4 through the set of parentheses. So if I was to distribute that 4 through the set of parentheses, I would end up with 4x minus, and 4 times negative 3 is 12. Okay? And we're just going to keep going. So then we've got 3x minus 3 plus x minus 9. So with this one, we just have to combine like terms. So we've got a 3x and a 1x. That's 4x. And then we've got a negative 3 and a negative 9. That makes negative 12. Okay? I'm going to kind of... right here, I guess. I'm running out of room. Then on the next row, you have 4 times x plus 1/4. Okay, and when I distribute that, I end up with 4x and then 4 times a fourth is 1. Then the next one is 1/2 times 8x plus 6. And when I distribute, minus 6, sorry. When you distribute that 1/2 through, basically all you're doing is taking half of each of those numbers. So you end up with half of 8, which is 4x, and half of -6, which is -3. Okay, and then the next one on that row is 8x divided by 2. And so all I do is take the 8 divided by 2, and I end up with 4x. I could be putting boxes around these so I knew which ones were my simplified version, huh? There we go. And then that one stayed. Okay, and then on the last one, you've got 2x plus 2x minus 3 plus 4. All I have to do is combine like terms here. So 2x plus 2x is 4x. And then -3 plus 4 is a positive 1. Okay, and then we have 6x minus, gosh, my x's are getting a little sloppy, sorry. X minus 2 times x plus 1 minus 1. So the first thing we have to do is distribute this -2 through those parentheses. So we've got 6x, and then -2 times x is -2x. -2 times 1 is -2, and then -1. Now combine like terms. 6x minus 2x is 4x. And -2 minus 1 is -3. Okay, and then I've got one more, and I'm really running out of room. Oh, no, I don't. It's already simplified. So we just have 4x. It's simplified already. I don't have to do any work. Okay, so now what I want to do is find equivalent expressions. Equivalent expressions are 2 or more expressions that have the same value, which is written right there on our screen. So, for example, in this first box, and you guys don't have to write this, but let's say I've got the expressions that equal 4x. So one of them was already 4x, this one right here. And then this one right here started out as 8x divided by 2, but then became 4x. So those are equal to each other. Okay, let's do 4x minus 3 is our next one. So the first one was 4x minus 3. That one was already given to us. And then this one with the 1/2 8x minus 6, and then there was 3 of these ones, and then the one that was 6x minus 2 times x plus 1 minus 1. These are all equal to each other. So those are equivalent expressions. And the last one, or no, sorry, not the last one, there's 2 more. 4x minus 12. So you've got the second one that started out as 4x minus 3. And then the second one, which I can't see, which started out as 3x minus 3 plus x minus 9. Those are equivalent expressions because they equal the same thing once they're simplified. Then the last one is 4x plus 1. And that is this one right here. That was 4 times x plus 1/4. And then this bottom one, which was 2x plus 2x minus 3 plus 4. Those are equivalent expressions because once we simplify them, they equal each other. So on Delta Math, when you go to do your assignment, it's going to ask you either to find an expression that's equivalent to the one given to you, or it's going to give you a whole bunch of choices and you have to pick the 2 that are equivalent. Okay, so it might be kind of like what we just did, where you just have to simplify a bunch of them, and then eventually you'll find 2 that are the same, or it'll give you one, and then you'll have to find the one that matches. Okay, and that's it. That is all of Unit 1, guys. Thanks.